Detecting objects in coordinate scenario is of great practical, and in this work we propose a simple framework to address such problem. Let's take a look at the details of our work. An anchor proposal can overlap more than one object in the same time. It is feasible to take it as a reference to predict multiple detection boxes that can include different objects. What's more, the well-adopted post-processing method for object detection seems vulnerable to cope with the intra-class occlusion problem. The smaller series will remove true positives, and higher one will introduce more false positives, which can be depicted in the image below. So the bounding box indicates the reserved detection result, and the dotted ones are the missing detections removed by post-processing method by mistake. Based on the two aforementioned observations, we propose a framework to address the intra-class occlusion problem in a simpler manner. Firstly, we revise the traditional matching strategy to make one proposal or anchor output multiple predictions, which is illustrated in the image below. The conventional matching strategy requires each proposal to be the reference for only one ground truth, but our newly modified matching strategy permits one proposal or anchor to be the reference for multiple ground truths. After we opt multiple predictions for each proposal or anchor, they will map to different target objects for simplicity. And illustration, we make one proposal or anchor map to two different target objects at the same time, thus making these two different prediction map to the two different targets is a problem. We propose to list out the combination between the predictions and the targets. Each combination will produce one loss, and the minimum loss will be selected for backpropagation. To optimize the detector, we call such loss function as EMD loss, which is the abbreviation of osmolar distance. Since one proposal anchor predicts multiple different detection results, therefore the traditional crowdedness method can be revised to satisfy the new matching rules. Specifically, the crowdedness first sort out detection in descending order by the confidence score. Once a bounding box with the lower score overlaps the one with higher score exceeds the predefined overlap threshold, it will be suppressed. We add another new rule in the MS to keep the one with lower confidence score. If they come from the identical proposal or anchor, both of them will be returned. We call the revised MS as ZMS. Let's take a look in the MS. Below, box A, B, and C overlapped with each other and exceed the predefined threshold. Thus, B and C will be removed, and only A and D preserved after graded MS. In our proposed set MS, in the same case, AC will be preserved. Since they are derived from the same proposal or anchor, therefore AC and D will be returned at last after the set MS. The framework is shown in this slide. As for implementation, we utilize FPN as the baseline. More than one RCN except the region of interest pooling is adopted on the identical proposal. The multiple prediction will be obtained, and EMD loss is utilized for optimization. The refinement model is optimal given the case one proposal or anchor overlap one target, but the different prediction has high score. The refinement model can provide a tunnel for these different predictions communication with each other. Thus, one of them will have a high confidence score, and the others contain small ones. Then we next we will demonstrate efficacy of the proposed method. FPN is adopted as the base detector with the proposed gamma. The data is trained on CrowdHuman training dataset and tested on validation dataset. MAP, MMR as well as MGA are utilized as evaluation metric. Higher value of MAP, MGA indicate better performance, which is in contrast to the MMR. We also do some ablation study on different kinds of module combination. The performance of different K is also conducted. Okay, the performance of COCO and CityPersons respectively are listed in the below. We also conduct the result. The result on the crowded testing data is listed in this table. Detecting result realization is also provided. Okay.